So here's our setup for M5, the little electric motor. We've got a power supply here in the back. Right now that's reading 5.4 volts and 0 amps. The line from the power supply output goes into this ammeter, which is reading 0 right now. Next, from the ammeter into the switch here, which you can see is open, and then from the other side of the switch to our electric motor input, and then it's going to run through the motor and out back to the power supply. So when we close the switch, the current will run through the motor. Let's take a closer look at the motor before we turn it on. So on the motor, the current is going to come in on the red wire here, and it's connected through this metal block to the finger here. This finger, or brush as it's commonly called in motors, is in physical contact with the commutator, which is a split ring on the rotational axis right here. So the commutator is in two halves, and one half is touching this finger right now. The wiring from there goes down into the coil of the rotor, that's the rotating part. And through the coil of the rotor, it's going to go back up to the other side of the commutator, which is right now touching this back metal finger, and then back out to the exit. So the current will flow down and through the coil, but the function of the commutator is to switch the direction of the current. We'll take a look at that next. So normally when the motor is operating, there are two permanent magnets held here, creating a magnetic field going across. I've removed them right now so we could take a look at just the magnetic field of the rotor. And I have the current turned on. You can see back there we've got 2.63 amps right now. And the motor's not doing anything because there's no external field for the rotor to interact with. But you can see if I hold up this compass, the magnetic field is coming out towards us right now. But as I rotate it around, it's still facing out of the coil until I get to about here, at which point the magnetic field switches direction, and it was pointing out this side, but now it's pointing in that way. And so if I go back across that transition, you can see the field flipping. That's from the commutator changing the direction of the current in the coil. And so the magnetic field produced by the coil changes. So now we can set the magnets back up. Let me turn off the current. And I've got a north end right here. And I'm going to put a south end on the other side. And we can take a look at that with this compass here. You can see the needle is pointing, the red side is pointing to the right, so that's the way the field lines are going. The magnetic field is coming out of this pole of the magnet on the left, going into the one on the magnet on the right. So the magnetic field is going across to our right. And so now when we energize the coils, the field from the coils is going to be pointing out, and it's going to want to line up with the field from the permanent magnets. So if I switch it on, the motor starts spinning, and as long as I keep it switched on, the current will change directions here, and so now it's going this way, but the rotor's moving, and so it'll keep moving around, and around here it'll experience a large torque wanting it to line up again with the field. And so every time it goes halfway around, the current flips and it has to keep moving to line up with the field in the new configuration. You can see one of the problems with DC motors in this kind of arrangement. If I switch on the current, but the motor is in this position, nothing happens because it's already lined up with the field. So what we've got to do is have it perpendicular for starting, and now if I switch it on, it'll get that initial kick, which will get it spinning around.